15.
Hello. Oh, let me just turn this over. I haven't got any slides, so you're just going to have to look at me, I'm afraid. So I'll try and make this interesting. I cut my finger at the weekend. I had the end of a nub of a loaf of bread. I was trying to cut it. I was trying to get 2 pieces of bread out of that. It was a bit of a stupid thing to do. I was holding the shiny crust. I was sawing through. The blunt bread knife slipped. It went into my finger. Blood everywhere. Luckily, my immune system is much more clever. Straight away, immediate reaction, inflammation, the end of my finger swelled up, it became hot, and that was my immune system rushing there with cells, with chemicals to try and cut off the capillary flow, to clean up the dead blood cell, the dead skin cells, mop them up, take them away, to protect my body against the invasion of any pathogens that come in with a knife. It was very successful. If you look at my finger now, it's not swollen. There's no inflammation. Inflammation's gone. It's nicely healing. In a month, you won't even know that my finger's been cut. So immune system's really, really important. But in some people, it goes awry. They get chronic inflammation. They get an immune system which doesn't turn off. They suffer from disorders like inflammatory bowel condition, Crohn's disease. They have eczema. They have asthma. They have rheumatoid arthritis. What happens is the inflammation continues past an injury when there's nothing, there's no reason for the inflammation, there's no need for an immune response. And the body actually starts attacking its own healthy cells. It can do a lot of damage like that. You can lead to some very painful chronic conditions which we don't have cures for. It's a big problem. Let me take you now to the Netherlands, to Amsterdam, to meet Maria. So she was very active. Dutch people anyway are much more active than us, but she was a very active woman. She's a former competitive gymnast who worked as a coach in athletics. She helped disabled people make the most of their bodies. In her late 40s, she realised while trying to pull on some socks and finding it pretty impossible that she had a problem. It had been getting worse. She'd been trying to ignore it. She went to the doctor, rheumatoid arthritis. It was a big blow. It was hereditary in her family, so she was worried she might get it. Over the years, she became more and more disabled. She had to give up her job. She couldn't get there anymore. At some points, she was reduced to a wheelchair. She was given drugs for her disease, and one of the drugs was one of these very new drugs called biopharmaceuticals, which were specifically attacked the inflammatory chemicals that were causing some of the inflammation. So rheumatoid arthritis is when the immune system attacks the joints. So you get inflammation around the joints. They become increasingly difficult to move. They become swollen. You can get bone and joint deformity growing. It's a really crippling disorder. She was worried she was going to end up in a wheelchair. The other drug that she was given, she was given steroids, she was given drugs to dampen down her immune system. And as I've explained with my finger, we need that immune system. We don't want to bleed to death. We don't want to get septicemia. We don't want to die of things that are very treatable by our body's immune system. So there are lots of side effects to steroids, to anti-immune drugs. They worked for a while, these drugs, slightly, but the condition got much worse. She started getting acute episodes where she was so disabled she couldn't move. She was rushed to hospital. She was, in the end, on a drip every now and again with anti-cancer drugs to try and get her some mobility. The future looked very bleak for Maria, a future of disability, of regular chemotherapy. Let me take you over the Atlantic to New Amsterdam, as it was once called, to New York. Kevin Tracy, an American, when he was 5 years old, his mother died of a brain tumor. This massive life-changing experience made him fascinated with the mind, with the brain, and trying to heal it. He became a brain surgeon. While he was training to be a brain surgeon, he went, as medical students do, through various residencies. And one of his residencies in A&E, an 11-month-old baby girl was brought in with severe burns all over her body. It was touch and go whether she would survive. But she started getting better. She got over the hump. She was getting much weller. And then, suddenly, bam, massive inflammatory immune over-response, toxic shock syndrome. She died in Kevin Tracy's arms. This life experience made him uber aware of inflammation. He was a brain surgeon that thought about inflammation. It made him perhaps more open to an important insight that he found when he was doing some research. He was looking at the effect of stroke in the brain. He was experimenting with rats. Now, stroke, a lot of the damage that's caused when somebody suffers stroke is to do with the inflammatory response. When you get inflammation in the brain, that can cause a lot of damage. So he was experimenting by putting a few drops of an anti-inflammatory medication into the rat's brain to see what effect it has. And something quite surprising happened when he did this. He got a reduction of inflammation in the brain, but he also got a reduction of inflammation in the rat's spleen. Now, this was impossible because, first of all, the brain is surrounded by a blood-brain barrier, so it's very difficult for pathogens, but also drugs, anything to cross that. But even if this drug had crossed the blood-brain barrier and somehow got through the bloodstream into the spleen, that tiny amount of medicine that was put in the brain would never have been in the spleen in a big enough concentration to have caused any change in inflammation, and yet it did. So what was going on? Well, this was Kevin Tracy's amazing insight. He realised that the only way for that reaction to have occurred was for the anti-inflammatory reaction in the brain to be controlling via the nerves an anti-inflammatory reaction in the spleen, in the rest of the body. And there is a nerve, the vagus nerve. It runs from the back of your ears right down through the neck to the chest. It wanders around. It's called the wandering nerve. Vagus means wandering in Latin. It wanders around all the other organs in the body. Now, this is an extraordinary thing to get your head around. It's a paradigm shift in how we see the brain and the body, of how they interact. What he was really saying was that it's the brain that controls inflammation. It's the brain that controls the immune system in the body. So, if we want to treat inflammation, if you want to treat diseases in the body, maybe you can treat them by affecting the nerves. And the nerves are an electrochemical system. So through electricity, you can trigger an immune response somewhere else. Well, this is hugely exciting because there are so many diseases that we cannot adequately treat at the moment that are immune-based, from cancers to diabetes to obesity to rheumatoid arthritis. Anyway, let's go back across the Atlantic now to old Amsterdam. A leading light in rheumatology, professor of rheumatology at the University of Amsterdam, Paul Peter Tack, was looking at this very problem. He had a waiting room full of people with a disorder that he couldn't treat, rheumatoid arthritis. As people get older, these people are living longer, they're crippled. They were in wheelchairs, they were on horrific medications that were only partially effective, they were all suffering symptoms. He was looking for an alternative medicine, an alternative way of treating these people. He got in touch with Kevin Tracy, found out about his work. The two collaborated and they said, look, let's see if we can treat these patients electrically via the vagus nerve. Because what they thought was happening was that the normal reaction that we get when my finger is starting to heal, my brain is now receiving sensory information. 80% of the information travelling up and down the vagus nerve is sensory. It's coming from the body's organs and cells, telling the brain what's going on. The information's received there saying, oh, my finger's all right now, and the brain is then sending back the information saying, switch off the immune system, switch off that response. But for people with rheumatoid arthritis, with Crohn's disease, with asthma, that response is too weak. It's not switching off. The inflammatory response is chronic. It's continuing. The body is attacking its own cells. What if they could boost that signal down the vagus nerve? So anyway, they needed patients, lots of patients, but they thought, well, we'll put an advert in the newspapers in the Netherlands. We'll try and find hopefully 20 patients, because that's enough really for a small trial, and see if this is going to work. They weren't that hopeful because, this isn't just taking another drug, see if it works. This was going to involve surgery. You needed to implant a pacemaker under the skin to get this to work. They hoped for 20. They were overwhelmed. More than 1,000 people with severe rheumatoid arthritis applied, begging to be on the study. Maria was one of them, and Maria was lucky. She was one of the lucky ones who got the pacemaker. They implanted it in the chest with wires that went up to the vagus nerve in the neck. She was given a magnet to swipe across to activate the pacemaker, which would stimulate the vagus nerve. They had no idea, should they do this for, half an hour? Should they do it for a minute? They decided 3 minutes a day, we'll give that a go. 6 sessions of 3 minutes a day, 30 seconds each. Off she went to try it out, and the researchers sat back, were hoping that it would make some sort of difference. The results were astounding. It made a huge difference. 20 people, 16 out of 20 of them, immediately got a massive improvement in their inflammation, in their symptoms. Maria, she's ice skating, she's cycling everywhere, she's back at work, she's doing basketball, really, really big. She's doing much more exercise than me. Anyway, a third of this group went into total remission. Essentially, they are cured of rheumatoid arthritis. I mean, it's really quite amazing. They have to keep this going, otherwise the symptoms come back. They have to keep swiping. They have to keep the pacemaker in. Nobody wanted the pacemaker taken out. But this is really interesting, not just because of this one study, but because what it really says about the way the body works and what potentially we could do. This is electromedicine. This is the future of medicine. So we have different vagal tone. Some people's vagus nerves work better than other vagus nerves. The vagal tone is how quickly, you can measure it in how quickly your body recovers after stress. So if your body recovers quickly after stress, you have high vagal tone. If you have high vagal tone, you're much more likely to be healthy, to be socially and psychologically healthier, to have a better outlook in life, to be happier, to have less depression. So the next step is to try and improve your vagal tone. And researchers have found there are various ways of doing this. You can do it through exercise, through meditation, but you can also stimulate it, as this pacemaker has done. And people are now trying it successfully for obesity. There are trials now in Crohn's disease. There are trials in various other disorders. Eventually, perhaps, we will have injected into our bodies precise and specific targeted electro treatments for a whole range of immune diseases. So, when I say that I was stupid to cut my finger, I was stupid, but my brain was actually really clever. It was monitoring my immune response. It was responding really accurately. It was working with my body. They're all so well connected. Thanks for listening.